Hello students, today I'll be explaining Banker's algorithm. Here I have taken one example to explain you the concept. In this algorithm, I have taken all these terms: allocation, max, available, need. I have explained what all these terms mean. Now here you have to remember what available means. Available is nothing but the available number of resources in the system. Available is nothing but work. And one more point you have to remember that after the process finish off its work with the resource, it returns the resource back to the system. That also will be available to the remaining process in the system. Okay. Now in this example, I have taken 5 process P0 to P4. And this A, B, C means resource types. Resource types have considered as A, B, C. And these allocation means these are nothing but the number of resources, instance of resources that are allotted to each of these processes. Now, here in this problem, they have asked you to determine the sequence in which the process need to be allocated the resources in order for the system to be in the safer state. Safer state means to avoid deadlock from occurring. Now, initially, this data will be given only till here it will be given. Need will not be given for you. You need to calculate the need. How do you calculate the need? This entire column will be empty. This entire column will not be given for you. Only this 3 columns will be given for you. Right? So this need you have to add. Need column you need to add and calculate. How do you calculate the need? By using the formula max minus allocation. Max they have already given here. Allocation also they have given here. Okay. For P0, calculate max minus allocation. Write on the values here. That is 7 minus 0, 5 minus 1, 3 minus 0. So you get 7, 4, 3. In the same way, you will be calculating for the rest of the process. For P1 it is 3 minus 2, 2 minus 0, 2 minus 0. 1, 2, 2 you will get. Similarly, you will calculate for the rest of the process. Now, after calculating the need, using the Banker's algorithm, you need to check out whether these are nothing but the number of resources that P0 requires, P0 needs to complete its work. And these are nothing but the available number of resources in the system. So using this formula, we'll see whether whatever P0 required it needs, whether it can be given by the system or not. Okay. Now if you check out need is nothing but from this table we'll be taking 743 is less than or equal to work. Work is already what they have mentioned is 332. Whether this satisfies? No, this doesn't satisfy. Okay, so P0 can't be given any process now. Now we'll move on to P1 process. For P1, what is the need of P1? 1, 2, 2. 1, 2, 2 is less than or equal to the work, that is 3, 3, 2. Yes, this satisfies. Now, after this satisfies, you have to calculate the work by using this formula. That is work is equal to work plus allocation. What is the work? Work is nothing but this value 332. 332 plus what is the allocation value? Allocation value from table you have to take for P1 200. 200. What is the value after calculating this? It is nothing but 532. Okay, fine. So this value you need to update in this table. Now the new work what you have calculated by using P1 process is 532. So meanwhile, after you get any one process into the safer state, you need to write the sequence, safe sequence here. That is P1 is the first process which enters the safe sequence. Likewise, you need to calculate for the remaining process. Next is P2. What is the need of P2? It is 600. It's less than or equal to work. You need to take down the new work what you have updated to the table. That is 532. Is this less than or equal? No. So you need to proceed to the next process. So here it is 1 0 0 is less than or equal to 5 3 2. Yes, this is correct. So calculate work is equal to work plus allocation. What is the work here? It was 5 3 2. The new value plus allocation is 2 1 1. Allocation is nothing but from the table I have taken here, from the table allocation of P3. Now what is the value here? 7 4 3. This is the new value. This value we need to update into the table. It is 7 4 3. Next process which entered the save sequence was P3. You need to update it here also. Next is P4. P4 it is need of P4 is 431. From this table have taken need. It's less than or equal to the new value, whatever you have updated into the table, right? That value you should take as work. Is this correct? Yes. So calculate work is equal to work plus allocation. What is the work here? 7 4 3 plus allocation of P4 is 0 0 2. This value. Okay. So the value is 7 4 5. This value you update here 7 4 5. And here also P4 is the next process which enters the save sequence. Now after finishing off with all the 5 processes, you have to repeat for the process which didn't enter the system in the safer state. That is P0 is left out and P2 is left out. Now you need to take P0 now. What was the need of P0? It was 7 4 3. Is less than or equal to, what is the new work you have updated? 7 4 5. Is this correct? Yes. Now calculate work is equal to work plus allocation. What is the work? New work we have updated 7 4 5 plus allocation of P0 is 0 1 0. So it is 7 5 5. Okay, this value you need to update here 7 5 5. So the next process which entered the save sequence is P0. Next, the remaining and the last process left out is P2. What is the need of P2? From here you should take. It is 6 0 0. It's less than or equal to the new work what you have updated 7 5 5. Yes, this is correct. So calculate work is equal to work plus allocation. Work is 7 5 5 plus the allocation of P2 is 302. 302. So what is the value? 7 plus 3, 10. 5 plus 0, 5. 5 plus 2, 7. This value we need to update it here. 10, 5, 7. The last process which entered is P2. So now this is the save sequence of the system. That is, if the process is given the resources in this fashion, in this sequence, then the system will be in the safer state. That is, you can avoid deadlock if you allocate the resource for the process in the same sequence. This is how the Banker's algorithm works. Thank you.